Step 4 for building an IoT application, use NeoFlow to set up your business data processing logic. After creating the OT device profile and IT service profile, the next step is a bit more complex. You'll need to use the NeoFlow designer to construct data processing and computation flows. This video will provide 2 examples for your reference. Let's get started. Click the Create NeoFlow wizard in the upper right corner. Step 1. Set up basic NeoFlow information. Enter the name of this NeoFlow. Please note that NeoFlow names within the same project cannot be duplicated. The encode field currently provides the globally standard UTF-8 encoding. The content type field offers the widely used JSON format. The date-time format field offers the ISO 8601-2004 format. If you need another, let us know. The time zone field defines the time zone for data sent from the gateway to the IT service. Example 1. In a factory with 3 identical PLC production machines, the gateway must connect to all 3 PLCs simultaneously, sending separate data to an MQTT broker set up by the IT department. Click Next to proceed to Step 2, set up the data sources. Click the Add OT Device from Profile button in the top right corner. In the OT Device Profile (PLC) section, click the Add button 3 times to add 3 PLC OT device profiles. Click Close to return to the NeoFlow settings page. For the first PLC, click Edit and provide the correct settings for this PLC, such as device name, IP address, and port. As shown on the page, assign the correct device name, IP address, and port for each of the 3 PLCs. Click Next to proceed to Step 3. Set up the data destinations. Click Add IT Service from Profile in the top right corner. You only need to add one MQTT broker. Click Close to return to the NeoFlow settings page. Click the Edit button for the MQTT broker and provide the correct settings, such as IP address and port. Click Next to proceed to Step 4, set up the messages. The IT department needs to receive messages generated by the PLCs. Click the Create Message button 3 times in the upper right corner, which will generate message_1, message_2, and message_3 by default. For easier identification, rename message_1 to PLC_11, set the message publish mode to time, the publish interval to 10 seconds, the message contains to all, and the maximum message size to 128 kilobytes. Click Add Tag to add a custom tag. For tag name, enter device name, select static as the data class, and enter PLC_11 as the default value. Next, click Add Tags from OT Device to add all tags from PLC_11 to the message. As shown, configure the other 2 messages similarly. Click Next to proceed to Step 5, link the data points. The left side of the screen shows the OT devices, data sources, and the right side shows the messages you just created. Select the OT devices radio button to enable auto-linking by name, then click Auto-Link. The system will automatically link OT device tags to matching message tags. Do the same for the other 2 messages. Click Next to proceed to Step 6, link the IT service. The left side shows the 3 messages you just set up, and the right side shows the IT services you can link to. Connect the headers of the messages with the headers of the IT service. NeoFlow will automatically generate a default topic name, which is the information needed to publish to the MQTT broker. You can modify the topic name based on the IT department's requirements. Finally, click Create to complete the first NeoFlow example. Example 2. In a factory, there is a motor with a vibration sensor to collect vibration data and a smart meter. The gateway needs to send 2 independent messages, as follows. Message 1, every 30 seconds, send the motor's vibration data and smart meter data to Azure IoT Hub for AI and big data research purposes. Message 2, if 2 instances of excessive X-axis vibrations occur within 30 seconds, immediately send an alert to the IT department's MQTT broker. Click Next to proceed to Step 2, set up the data sources. Click Add OT Device from Profile in the top right corner. Add a vibration sensor OT device profile and a power meter OT device profile. Click Close to return to the NeoFlow settings page. Click Edit for the first vibration sensor and provide the correct settings, such as device name and data read delay. Similarly, configure the second power meter. Click Next to proceed to step 3, set up the data destinations. Click Add IT Service from Profile and add both Azure IoT Hub and MQTT Broker Service. Click Next to proceed to step 4, set up the messages. Create 2 messages, vibration_message and alarm. For vibration_message, set the publish mode to time with a publish interval of 30 seconds. Add the tags from the vibration_sensor and power meter. For the alarm message, set the publish mode to condition and manually add the following fields. Alarm name, static, with a default value of motor failure alarm. RPM, tag. X_overall, tag. Click Next to proceed to step 5, link the data points. The left side shows the OT devices, data sources, and the right side shows the messages you just created. Click Auto Link for the vibration_sensor and smart_meter to link the tags to the vibration_message. Then, click Add Process in the upper right corner to add a tumbling window component. Set the return type to counter and the time interval to 30 seconds. Click Add Process again to add a condition component, set the type to greater equal, data type to float, and value to 2. Connect X_overall_QC to the tumbling counter tag, then connect the tumbling counter out to the greater equal tag, and link greater equal out to the alert_message header. This completes the data flow logic for the alarm message. If more than 2 abnormal X-axis QC values occur within 30 seconds, NeoFlow will trigger the alarm message. Click Next to proceed to step 6, link the IT service. The left side shows the 2 messages you just set up, and the right side shows the IT services you can link to, including Azure IoT Hub and MQTT Broker. Connect the vibration_message header to Azure IoT Hub and the alarm message header to MQTT Broker. NeoFlow will automatically generate a default topic name, which is used for publishing to the MQTT Broker. You can modify the topic name according to the IT department's requirements. Finally, click Create to complete the second NeoFlow example. Through these 2 examples, you should understand that NeoFlow is a framework for data flow and processing. We will continue to offer more diverse processes to meet your needs. You can also develop custom process plugins using the NeoFlow Python SDK. If you need any customizations, feel free to contact us.